All right, so if we take a look at problem 51, if you remember yesterday, there was one main idea when we're solving equations, okay, in this chapter, whether it's exponential or logarithmic. It was get the exponential or logarithmic part by itself first, then switch forms. Okay, if you're in exponential, switch it to logarithmic. If you're in logarithmic, switch it to exponential, and then solve. That's the main. That's the main idea of what we did yesterday. Okay. So if you look at this, this is an exponential equation because we've got the variable and the exponent, which means I need to solve for the base. This looks worse than it is because all of this is the base. All the stuff that's in the parentheses is the base, which you need to actually go through and do. Okay. You can clean this up and actually get a number here that's a little bit better. So if you divide the 0.10 by 12 and then add 1, what do you get? Somebody help me out as you work your way through this. What does the stuff in parentheses actually equal? 1 point what? What is it? 008. Okay. So if we 1.008 to the 12t power equal to 2. Now it looks a little bit nicer. It's back to, this is just an exponential equation. The base is by itself, which means now I'm ready to switch to logarithmic form. Okay? So if we switch this, log base what? 1.008. Bases are always the same. So 1.008 equal to? Yeah, remember it's always the log always equals the exponent. So equal to 12t, which means 2 is the argument. And now at this point, if you take a look, the left-hand side, we can just plug into the calculator and then divide by 12 and you've got your answer. Okay. So there's the idea on the first one. Like I said, get the base by itself, clean it up. Then from there, switch it to the opposite form and then solve the resulting equation. Okay. You can plug the left-hand side into the calculator, divide it by 12, and you got your answer for t. Okay. By the way, quick question. Do I need to check this for extraneous solutions? Why not? You're right, by the way. Lucky guess. All right. Fair enough. Why not? Anybody tell me? What's the domain of an exponential equation? All real numbers. Remember back to the graphing idea, we had said the domain of exponential equations are all real numbers, which means the answer can be anything. You don't have to worry about it. It's the logarithmic ones you have to make sure you check, because the domain of a log is not all real numbers. It's restricted. So you got to double check that. Okay. All right, let's do one more. Let's take a look at 53. This one also is pretty messy. So again on this one, if you keep in mind your goal of what you're trying to do, if you keep one main idea in mind, it helps the process. Okay, and what I mean by that is we've got an exponential equation again, because I've got a variable in the exponent, which means this stuff that's in parentheses is the base. When you solve exponential equations, you need to get the base by itself. So that 0.005, we have to get rid of that. The 5,000 out front, we've got to get rid of that. I need to solve for the numerator before I do anything else. And that's why I said, if you keep in mind what the goal is, trying to get the exponential part by itself, it makes the problem a little bit easier. Okay? So there's a couple ways you could do it. Personally, I would take and divide both sides by 5,000 to begin. Get the 5,000 out of there. Okay? So we end up with 1 plus 0.005 to the x power over 0.005 equal to, when you divide by 5,000, correct me if I'm wrong on that one, it's 50, right? I think, yeah, okay. So we get 50. Now, same idea again. I'm trying to get the base by itself, which means I need to get rid of the 0.005. So we multiply both sides to get rid of that. I'm going to clean this up right away as well. Once again, I can get an answer in the parentheses. So I'm going to write this as 1.005 to the x power equal to, when I multiply both sides, what do we get? What is 0.005 times 50? 0.25, okay. And now we're right back to an exponential equation again. You've got a base raised to a power equal to something, which means now we're ready to switch it into logarithmic form. Okay? So you had to clean it up a little bit, and now we can move forward with solving. Which means in this case, let's switch it into logarithmic form. Log base 1.005 of 0.25 is the argument, 1/4, equal to the exponent, which in this case is x. And the nice part about this one, there's no extra solving to do at all. X is already by itself. All you got to do is type it into the calculator and you've got your answer. Okay. So these problems, thinking back to the test idea, these problems would be calculator type problems, obviously. Okay? These would be day 2, where you'd have to go through and solve for that value of x. How we doing? Making some sense? Doing okay after seeing that? Hopefully. Like I said, biggest thing is when you look at a problem like this, you see something like that, and I know it's very easy to get overwhelmed. Like, holy cow, where do I even begin? Think about what the main goal is. I need to solve for the exponential part. That should at least get you started then. Like, okay, now how do I do that? And then you can start working your way through the process. Any other questions you have from homework? Anything else that you wanted to go over? I figured those two were probably the two that I needed to go over together. All right, let's get into what we're going to do today then. So here's our objective is a continuation from yesterday of continuing to solve exponential and logarithmic equations. Okay? But today, nothing new. Practice. Okay? Let's practice when to use a calculator, when not to use a calculator. Let's practice let's go through the process. Just like I said, it's just going to be a back and forth kind of today. So here's the first one. Do those two problems without a calculator. Here would be day 1 type problems on the test. Okay, when I said that there's some log problems you should be able to do in your head, these are the types I was referring to, okay, or at least a couple of the types. See if you can get some answers. I'll give you a minute or two here to see what you can come up with. No calculator. No calculator. See what you can do. We got to evaluate some logs. Welcome back, by the way. I know you're super excited to be back. I know. I get it. You done yet? All right, let's take a look. Here's why I say, are you done yet? Okay, here's what you should, hopefully, there's multiple ways to solve this. Here's the way I would go on both of them. We have a property on the first problem. What can I do with that exponent? We can bring it out front. Remember when you take the log of something to a power, you can always bring the power out front. So this is really 2 times the log of 1,000. What's the log of 1,000? What's it equal? You should be able to do this in your head. Nope. Somebody said 3. 3. Why? What base are we doing? 10 to what power gives you 1,000? 3. This is just 3 times the 2 that's out front. There's your answer. It's 6. Okay? The log of 1,000 really is saying 10 to what power gives you 1,000? Okay? 10 raised to what power? 10 squared is 100. 10 to the 3rd power is 1,000. Okay? When you look at the second one, again, there's a couple of ways you could do this. The easiest way is just evaluate it directly. What's the log base 3 of 27? 3. And again, remember what's being asked is 3 to what power gives you 27. That's what a log tells you. This is 3 plus, what's the log base 3 of 81? 4. And 3 plus 4 gives you 7. There's your answer. Okay, so giving you a heads up, these are the types of problems when I say on You know the first thing you're going to be responsible for being able to do? Some problems like this. Okay? Probably 5, 6, 7 problems just like this. Where you go through, here's some log ones, evaluate them, get an answer. Okay? So that'll be the first thing you take a look at. All right, let's keep going. Example number 1 here. We've got an exponent. We're solving an exponential equation. This was also a no calculator type of problem. Okay? I told you there's 3 types of things on the no calculator part. One of them was like we just did. 2 are the graphs, which we'll talk about as we get closer to the test. We'll revisit that again. And 3 are solving equations. Okay? This would be a no calculator one. Remember, step number 1 we said was, if you can reduce to the same base, you should. Okay? If you can't, then that's where you go to the calculator. Here's what I mean by that. I'll do step number 1, and then you take it from there. 8 and 4 are both powers of 2. So 8 is really just 2 cubed. That then is still re-raised to the x plus 1 power. 4 is just 2 squared, which is then raised to the x power. And from here, you should be able to solve it, hopefully. Okay? Like I said, you don't need a calculator to get x. What do we do when we have a power to another power? So like in the first one, I've got a cubed and then it's to the x plus 1. What do I do with those? Multiply. Remember your properties of exponents. Power re-raised to another power, you multiply the exponents. So this is going to become 2 to the 3x plus 3 power. Okay. Distribute the 3 to the x times the x plus 1 equal to 2 to the 2x power. And we said yesterday, if the bases are the same, then now you just need to worry about getting the exponents equal. So now I can just focus on 3x plus 3, therefore has to equal 2x. And now we're right back to algebra 1. Solve for x. Okay. Subtract the 2x over, I get x. Subtract the 3 to the other side, we get x equal to negative 3. And there's your answer. Okay. So you will have a few problems like this, like I said, on day 1 of the test, where here's some exponential, reduce the base, get them the same, set the exponents equal, things like that. Okay, you will see problems like this on day 1, next Monday. Okay, doing okay so far? Hopefully. All right, let's keep going. Here's another one: logarithmic equation. This one could be on either day, to be honest, and you'll see why when we get there. This one could be on the calculator day or the no calculator day, depending on how you put the answer. What do you think we should do first? Make this simpler. How do we make this simpler? Condense. You got 2 logs on the same side. Condense them into 1. Okay? So if I put these 2 logs together, since we're adding the logs, that means we multiply the arguments. So this becomes the natural log of 2x equal to 4. And now you're right back, just like we said yesterday. We haven't done one of these yet, but we said in general, when you're solving either exponential or logarithmic, get the exponential part by itself, or get the logarithmic part by itself, which it is now, and now change forms. We're going to put this into exponential form. What's the base? E. Raised to what power? 4 equal to 2x. And now this just got a whole lot easier. In order to get x by itself, all you got to do is divide by 2. Okay? And this is why I said this could be on either the calculator or the no calculator part. You could just leave the answer like this. E to the 4th divided by 2. Okay, that's fine. That's the exact answer. Or, if I had you type it into the calculator, you'd actually get a decimal version and round it, then it would be on the calculator portion of the test. Okay? But the only place you would need a calculator is right now at the very end. Okay? The solving process and the simplifying, you don't actually need a calculator for. Okay. All right, let's keep going. Try this one. See what you can do on this one on your own. See what you come up with. This would be a calculator one eventually. Okay, you will need a calculator to get the final answer for this one. See what you can do. Solve this exponential equation. Base by itself, change forms, solve. All right, let's take a look. Like I said, step one, get the base by itself. So I need to get the 10 to the x plus 5 by itself. So step one is add the 7 to the other side. So we get 19 equal to 10 to the x plus 5 power. And now, switch forms. Now we go to logarithmic form. So in this case, log base what? 10. So you can either write the 10 or not, since it's base 10. Doesn't really matter. Okay. In this case of 19, always equals the exponent, x plus 5. Okay. Log of 19 is where you're going to need the calculator. Okay, it's not, you can't take 10 to some nice power and get 19 as an answer. So there's your calculator, and then subtract 5 over. Okay. As we do this one, what do you get? What is the log of 19? Help me out. What is it? 1 point. Okay. 1.278 equal to x plus 5. Subtract the 5 over, and we get, what, negative 3.72. There we go. Yep, that sounds right. Is it okay that x is negative? Because I know a lot of times that's the first instinct is, oh, but I thought x can't be negative. Yeah. Exponential equation, remember the domain, all real numbers. X can be positive, negative, 0, anything. Okay? Logarithmic is where you got to go back and check. Okay? All right, let's do another one. Let's keep going. I told you we were going to go back and forth. Try this one. Solve for x. Get the log by itself. Switch forms. Solve. All right, let's see what you did. Again, this time get the logarithmic part by itself, which means I need to get rid of the 5, so we'll subtract that over. negative natural log of x equal to 2. And then the second part, you do need to get rid of the negative. Okay? The natural log, the log is, before you switch it into exponential form, you want the log of something. Okay, whatever, just the argument is the only thing you want, which means the negative's outside of that. So if we divide or multiply both sides, I get the natural log of x equal to negative 2. And now we can switch forms. Base, since it's a natural log, e, yep, raised to which power? Negative 2 equals x. Again, this could be either a calculator or a non-calculator day, because you could just leave it like that, which, by the way, if you simplified this, that's 1 over e squared. Same thing. Or, at this point, you could type it into the calculator and get a decimal version. Okay? So this problem could be, again, on either one of the 2 days. The only place you really need a calculator would be at the very end if you wanted to get an actual decimal version. Okay? How we doing? Okay? Getting the idea? Getting the hang of this? Hopefully? All right, let's keep going. Got a couple more. I got 2 more for you after this one. This one we'll get started here, and we'll kind of work our way through this one together, but see what you think. Looks messy. So we're going to clean it up. Any ideas of where I start? What do we do first? What do you think? Okay, super glad you said that. Okay, because here's what you were thinking, right? Let me go back for a second. I assume. So on a problem like this, we had said if the bases are the same, then you can set the exponents equal. And the other day, we had said, yesterday, we had said if you've got 2 logs that are equal, then the arguments have to be equal. Unfortunately, I can't do that here. Why? Because of the minus 1/2. That's not part of the argument. This is not, the argument is only the x. So if that wasn't there, then I could set x equal to x minus 1 and solve. I could try it. Okay? If one log equals the other, then the arguments. But because of that minus 1/2, it doesn't work out, unfortunately. So what do you think we should do? Other ideas? What do you think? Like I said, this one's harder. What if we do this? What if we try to get the logs together on the same side and kind of get that, we'll get that minus 1/2 to the other side. Let's just reorganize this a little bit. Okay. So I'm going to add the 1/2 to the right. I'm going to subtract the log to the left. Okay? And then you tell me what I do from there. Log base 4 of x minus log base 4 of x minus 1 equal to 1/2. Okay? So we just rearranged. I put the logs on the same side, I put the 1/2 on the other side. Now you got any ideas? Why divide? Condense the logs. Now that the logs are together, now I can condense those 2 logs into 1. Okay, that's exactly why I reorganized. So these 2 logs we can put together as the log base 4 of, since you're subtracting, we can change it in. First one's the numerator, second one is the denominator. We can combine 2 logs into 1. You can use one of our properties. And now, we've got the log by itself, so now we're ready to switch forms. Okay? Now we're ready to switch forms. Starting at the base, 4 to the 1/2 power is equal to our argument, which in this case is x over x minus 1. And now we solve. What's 4 to the 1/2 power? 2. Why is it 2? The 1/2 power is the square root. That's really just the square root of 4 is all that says. So this is really 2 equal to x over x minus 1. And now you can solve. You can either clear the fractions, multiply both sides by x minus 1, perfectly fine. Okay? Or you could think of this as like 2 over 1. and then use it as a proportion and cross multiply, whatever part makes more sense to you. Okay? Does not matter which way you do it. So if we take a look, if I multiply, we end up with, I'm going to distribute, we get 2x minus 2 equal to x. And now we solve. Subtract the x over, I get x equal to 2. Okay. Quick question, do I need to check this? Do I need to check to see if it's extraneous or not? Yeah. I need to just double check. And at that point, this would be granted I didn't need a calculator, but at that point, one, you're good that you don't have any negatives, but you would still need to just double check that you get the right answer. Okay? And in this case, you do. So an x equals 2 is the correct answer. All right, that one's a little bit more difficult, like I said, because of the fact that you had to rearrange stuff first, then start the condensing and solving process. I'm going to actually skip the next one only because it's kind of like 51 and 53 that we did from the assignment where you got to go through and clean it all up. And because we already did that, I'm going to skip that one. And I'm going to go to this one. This one we're going to do together. Okay? This you have not seen yet. So this is one I would not necessarily expect you to be able to do. Although, this one's kind of like a hidden problem. There's something going on here that once you see it, it'll make more sense. Okay, so when we look at this problem, just a quick heads up, I'm going to rewrite the first part. E to the 2x is the same thing as e to the x squared. Agree with me on that one? Power to a power, I would multiply those, I would get e to the 2x back. I'm just kind of pulling it apart. And then if I write the rest of this out, anybody see it? What kind of problem is this? Quadratic. This is a quadratic equation. This is a factoring problem. There's your term that's squared. Okay? If you don't see it, let me do one more step and then I'll kind of go back. If you don't see it, let's take the e to the x's and I'm going to say let's let e to the x equal y. Okay? So if I do that, let me take e to the x out and put y in here. I would then have y squared. Let me take e to the x out and put y in that spot. Now do you see it? It's just a factoring problem. But instead of factoring x and x, you're factoring with e to the x's. Okay? So it kind of fits with what we're doing currently. So that's the only difference is this is really just a quadratic equation. Okay? So let's go through and let's actually factor this. Instead of x squared, where we would put x times x, you've got e to the x squared. So we put e to the x and e to the x. And then the rest is just like the regular factoring. What's the rest of the factors going to be? What is it, Cooper? -5, -2. Yep. Those will add to 10, multiply to 10 and add to -7 to get your middle term. And then from here, once it's factored, how do I solve? Zero product property. Set each one equal to 0. E to the x minus 5 equals 0. E to the x minus 2 equal to 0. And now solve each of these separately. In this case, add the 5 over. And now, solve it. Switch it to logarithmic form. If we do that, we end up with the natural log, because it's base e, of 5 equal to x. Okay? If you're switching it into logarithmic form. And in this case then, you can either leave it exactly as natural log of 5, or you can type it into the calculator and get your final answer. There's one answer. And you do the exact same thing with the other one, but with the 2 instead. Add the 2 over. Switch it into logarithmic form. We end up with the natural log of 2 equal to x. And there's answer number 2 right there. Okay. Biggest thing I want you to see is this is really just a factoring problem. Okay? And these are one of the types of problems where you just kind of have to identify it and say, oh, this is that e to the 2x and then e to the x. This is a factoring one is all this is. And then work your way through the rest of it. Okay? This would be something, and again, I didn't really need a calculator until right here if I wanted to type in natural log of 5 and natural log of 2. But this is something that you'll see on the test as well. Okay? One more, last one. Let's go back to one like this. All right, what do I do first? What do you think? Step number 1, where do I begin? Here's what I'll tell you again. If you look at this problem, think of the big picture for a second, and then you work on the steps to get there. This is an exponential equation, which means I need to get the base by itself. I need to get that e to the negative x all by itself, so that then I can switch it to logarithmic form and solve. Which means if that's what I'm trying to do, if that's what I'm trying to accomplish, what's the first thing I do? Yeah, a couple of options. Yeah, you could clear the fraction, or again, like one of the earlier examples, if you think of this 275 as over 1, you really just have a proportion. Cross multiply. Okay? 275 times 1 plus e to the negative x equal to 525. Regardless of whether you clear the fractions and you didn't put it over 1, or whether you put it over 1, you get the same thing. Okay? Cross multiply. Now what? What comes next? Okay. You could either distribute the 275, or I would do exactly what Cooper said. I would divide both sides by 275. Get that out of there. Those cancel. We've got 1 plus e to the negative x equal to, what does that give you? 1.91. Okay, 1.91. Subtract the 1 over. Remember, we've got to get the e by itself, which means e to the negative x power equals 0.91. And now, once again, we've got it to the point where I am ready to switch this into logarithmic form now. You've solved for the exponential part. Now we're ready to switch forms. Since it's base e, we're going to natural logs of the 0.91 equal to negative x, the exponent. Plug in natural log of 0.91 into your calculator. What do you get, by the way? What is that? 0.094. Is that what you said? Okay. 0.09. Oops. Try that again. 0.094 equals negative x.
Oh, it's negative.
Which means x then is positive. And there's our final answer. Okay. Again, this is one I don't really have to worry about going back and rechecking it in the original problem, because we started with an exponential equation. Okay. Just the ones that start as logarithmic ones are the ones you have to go back and double check for extraneous solutions. Okay. My hope is that as you kind of work through some of these, you can kind of see, one, just some of the process that's making a little bit more sense of the idea. But then the other part as well is, what's a non-calculator problem versus a calculator problem? Okay, kind of getting the feel for when you use it versus when you don't. Okay, and the expectation that's going to be on the tests. So what I have for you, I switched the assignment from yesterday to a worksheet. Okay, so it's no longer a book assignment. I switched it to a worksheet. Okay, so let me give you this. And on this worksheet, all I want you to do are the every other odds. Okay, you don't need to do all the odds. Do every other odd. And the answers are on the back. Okay, the answers are on the back for this. So you can very quickly check to see if you're doing things right. Like I said, every other odd for the top section and the bottom section. So you're starting on 1, skipping 3, do 5. Skip 7, do 9. Skip 11, do 13. Okay, so you have like 10 questions to do. Top ones are all exponential ones. Bottom ones are all logarithmic ones. You will use a calculator on these, so it's not, you don't have to worry about calculator versus non-calculator. These would all be calculator type problems. Okay? This is just more practice of solving these types of equations.